We're going to get into polls and margin of error in this video, and we're going to start with this information. So nearly 2/3, 63% of cell phone owners now use their phone to go online, according to a new survey by the Pew Research Center's Internet and American Life Project. We call them cell internet users and define them as anyone who uses their cell phone to access the internet or use email. Because 91% of all Americans now own a cell phone, this means that 57% of all American adults are cell internet users. The proportion of cell owners who use their phone to go online has doubled since 2009. We're going to use all of this information to answer some questions here in just a minute. Now, this is kind of a graphic for almost 2/3 of all owners. The 63% they reference is here. You can see it's broken down into just email, just internet, and the line is total internet. I'm getting this from down here. You can see the source down here. N is the sample size. We see our margin of error. Again, we're going to use this information to answer some questions. And the first question here is number 1. You can barely see it. Where did this poll come from? And it says it on the first one. It says it here again. This is the Pew Research Center that did this. And, you know, you might say, I don't understand why you're asking that question. It doesn't matter. Oh, but it does, right? You would not trust a poll that was done, let's run a poll on favorite dog breeds if that was done by, people who hate dogs. Because it doesn't make any sense, right? You want to make sure that whoever's doing the research is a reputable company. If it's just, Billy from his backyard doing a poll about people walking by on favorite colors of grass, well, that doesn't make any sense, right? You want to make sure it's from a good company that actually does real research and doesn't just use maybe convenience data. You want real good data. Okay, population. Now, the population, by definition, is all possible people. That's the wrong way for a P. All possible people for a survey. Okay, so if I want to do a survey about, cell phone users, I want to talk to every possible person I can, and that want to cast a very, very wide net. Well, you can't talk to everybody, and so the sample is the number you actually talk to. Just think about it. You might want to talk to all people who like baseball. Well, there's 314 million people in the United States. You can't talk to all of them who like baseball. It's impossible. So you've got to talk to a sample. Ugh. Now, the population represented by this poll, let's go back to this picture. You can see here where it says N equals 2,076 cell phone owners ages 18 plus. The cell phone owners 18 plus. Population is all cell phone owners 18 plus. I mean, that's really what we're talking about. So basically we're talking about, and we're talking in Americans. So all American cell phone owners 18 plus. I say all because the population is the wide net that I'm casting in order to talk to people. Now in number 3, we know that you can't talk to everybody. So what's the sample? How big is the sample? And that's where the number comes into play. So the sample is 2,076 cell phone owners 18 plus. So 2,076. So the difference between a population and a sample is the population is all possible, whereas the sample has an actual number. How many did you talk to? Okay, let's go to number 4. How many people out of the 2,076 cell phone owners polled said they use their cell phones to access the internet? Well, recall that on the first page it said 63% of cell owners use for internet. So that's 63% of the 2,076. So 0.63 times 2,076 gives me 1,307.88. We're talking about people. You can't have part of a person. So maybe 1308 if you round to the nearest, 1307 if you truncate. It's, kind of depends on what you want to round to, but you need a whole number there to talk about people. And number 5, explain how the authors can conclude 57% of all Americans are cell internet users when they're only polling those who use phones. Well, remember that they talked about 91% of all Americans have a cell phone. And then they talked about 63% of cell phone users use it, right? So when it says all Americans use it, this is an and problem. They're American adults and they're cell internet users. And remember that back in the probability section, we talked about and meaning multiplication. Well, if you take 91% of all Americans and multiply by the 63% of the adults who are cell phone users, you end up with 0.57, which is 57%. So in order to be an adult American with a cell phone and a cell phone internet user, we would multiply those together to get the 57%. So it really becomes kind of a probability question there. Number 6, let's suppose another group of 2,076 American adults were asked the question, do you use your cell phone to go online? Would the percent who said yes always be the same, or would it vary? In other words, would you always get 63%? And the answer is no. We're not always going to get 63%. Would we expect it to be somewhat near that? I would say yes. In the ballpark, yes. Exactly 63? No, that's ridiculous. Unless you talk to the exact same person on the same exact days and get the same answers, there's no way to get the exact same answer. So if you would ask every American, so now we're not limiting to just a sample, would the percent be exactly 63? And again, the answer is no. We're expecting it to be something around 63%, but it's not going to be exact. It's going to be in the ballpark. And that leads us to the concept of margin of error. So the margin of error is the variation expected, really. Because we know that we could ask 10 people a question, get some answers, ask 10 more people, and the answers are going to vary group to group. So it's the variation expected. How far off can you be? And that is dependent on the sample size. Now, if you go back, sorry, I give you whiplash here, you see in this example that it says the margin of error is plus or minus 2.4 percentage points. So our margin of error is plus or minus 2.4 percentage points. So that means they might say 63%, but they're off a little bit. They could be off by plus or minus 2.4%. Okay? So to find our margin of error, right, we might say we would take our sample percent and we would subtract 2.4, which would be the margin of error, or we would take our sample percent and we would add our 2.4%. That gives us kind of our leeway. I'm going to be somewhere in this range. And when we talk about that range, we start talking about the confidence interval. So the confidence interval is really the range of accepted values. And that's based on the margin of error is how you find your confidence interval. Okay? So with this particular case, we know that we had our sample percent was 63, and we're going to subtract 2.4% to get the low end, and then we're going to take 63% and we're going to add 2.4 to get our high end. So we would end up with 60.6% to 65.4%. So if we would talk to a group of American adults, we would expect between 60.6% and 65.4% of them to be cell internet users. That's what this means. We give ourselves some leeway. Now, the 95% margin of error is what we are going to use in this problem. And for that, to find that, we would take it 1 over the square root of n, where n is the sample size. Okay? And this allows us then to say that we're 95% confident that the proportion of cell owners would be between these two. We can say we're 95% confident because we are using a 95% margin of error. And that's all we're going to use in this class. So let's just go ahead and find a few margin of errors to end out this video. Let's find the margin of error for a sample size of 1,095. Well, I would take 1 divided by the square root of 1095. Now, depending on your calculator, some of you might have to find the square root first and then hit 1 divided by that answer. Some of you will be able to type it in all at the same time. Either way, you should get 0.03, which is roughly a 3% margin of error. Now, in number 11, we have a bigger sample size. We go to a sample size of 2,000. So 1 divided by the square root of 2,000 gives me, that's not what I wanted to do, gives me a 0.022, which is roughly a 2.2%. So it is true that the larger your sample size, the smaller your variation and the smaller your margin of error, because you expect a larger sample size to be truer of your true proportion and be more accurate data.